Multiplying fractions is one of the simplest operations you can do with fractions if you follow this simple procedure. Let's look at this example right here, which is 1/4 times 1/4 equals the numerator of the resulting fraction would be the product of numerators, and the denominator of the resulting fraction would be the product of denominators. So in this example, our numerator would be 1 times 1, which is the product of numerators. And the denominator of the resulting fraction would be 4 times 4, which is the product of denominators, which is equal to 1/16. Let's look at another example. 2/3 times 1/5 times 3/4. So in this example, we have 3 terms. So how do we do that? So we follow the same procedure no matter how many terms we multiply. So our resulting numerator would be 2 times 1 times 3. That is the product of all numerators. And the denominator would be the product of all denominators, which is 3 times 5 times 4. And our answer would be 6/60. It's just that simple. Then why is this video longer than a minute? Well, some great minds don't blindly follow some procedure taught to them by teachers. They want to know why they should follow the procedure. So let's just explore. Think, what would have happened if Sir Isaac Newton never thought why apples fell down instead of going up? Well, we wouldn't have known about gravity, which is one of the base of all the inventions, all the important inventions in the universe. So it became one of the fundamental laws of physics, and it changed the course of science and mathematics. So if you have an investigative mind, you always ask why. So here, if 1/4 times 1/4 equals 1 times 1 divided by 4 times 4, then why 1/4 plus 1/4 is not equal to 1 plus 1 divided by 4 plus 4? Why you do not add the denominators? Well, someone says that's the procedure. Well, you don't have to always believe what someone says. You need to know why. So why is it 1 plus 1 divided by 4 instead of 1 plus 1 divided by 8? Why is it 2/4? It's a very valid question. To understand this, we need to know what is a fraction. Fraction is part of a whole or part of a group. It is written as 2/3, or we call it as 2/3. So 2 is the numerator and 3 is the denominator. And numerator and the denominator, they're separated by a division line. And what does the denominator represent? It represents the total number of equal parts in a whole. In this example, the whole is divided into 3 equal parts. And what does the numerator represent? Numerator represents number of parts we are talking about, or the number of parts in the context. Let's use an area model to understand this further. Here is a circle which is one whole. Since our denominator is 3, we have to cut the circle into 3 equal parts. So now we have 3 equal parts in our circle. Let's say numerator 2 represents the part, those are shaded. So we shade 2 of these parts. So fraction 2/3 represents the shaded part of the circle. Now that you understood how to represent part of a whole as a fraction, let's apply fraction to a real-life scenario and understand how addition and multiplication of fractions work in different scenarios. In this example, Maria invites 3 of her friends, Amy, Mia, and Anna, to her birthday party. She ordered 1 large pizza for all 4. So, what fraction of pizza each one would get? Including Maria, there are 4 of them. So, we slice the pizza into 4 equal parts. So, each one is going to get 1 slice. How do we represent that as a fraction? Just from what we learned, to represent a part as a fraction, first we have to write the denominator, which is the total number of equal parts in one whole. In this case, it is 4. So our numerator is going to be the number of parts in context, or the number of parts that we're talking about. So in this case, it is the one slice of pizza. So our numerator is just 1. So our answer to the question, what fraction of pizza each one would get, is 1/4. Now let's extend our question and find out what fraction of pizza Mia and Amy together would get. Previously, we found out that each one is going to get 1/4 of a slice. Mia would get 1/4 and Amy would get another 1/4. So what fraction of pizza Mia and Amy together would get? We just simply add these two fractions. And our resulting fraction is going to look like this. And how do we represent this as a fraction? So first we write the denominator. So the denominator is the total number of equal parts in one whole. So in this one whole pizza has 4 equal parts. So 4 would be the denominator. And what is going to be the numerator? So the numerator is the number of parts that we are talking about, or the number of parts in context, which is this one slice plus another slice. So which is 2/4. Here you can see that we did not add the denominators, because when you add two fractions with common denominators, the resulting sum will also have the same denominator. In this case, it's 4, as the total number of equal parts in one whole does not change. So in this case, the total number of equal parts in a whole after adding is still 4. But the method will be different when you add two fractions with different denominators. Say, for example, if you add 1/4 and 1/5, we cannot apply this method. So that's going to be different, and we are going to cover that in a different tutorial. Let's further extend the scenario. Let's say everyone else had their slice of pizza except for Mia. Mia saves her slice for later. 3 more friends of Maria shows up unexpectedly. So if Mia decides to share her slice, what fraction of pizza Mia would get now? Now, again, there are 4 people to share 1/4 of a pizza. So Mia cuts the pizza into 4 equal slices. Now Mia would get just 1 part of this 1/4. That is 1/4 of 1/4. So how can we represent this 1/4 of a 1/4 as a fraction? So to find the fraction of pizza Mia would be getting, we have to first find how many equal size slices one whole can be split into. So in this case, each fourth can be split into 4 equal sized slices. So our total number of equal parts in one whole would be 4 plus 4 plus 4 plus 4. That is 4 times 4, which equals 16. We know that fraction of pizza Mia would have equals 1/4 of 1/4, which is same as 1/4 times 1/4, because in fractions off implies multiplication. From this area model, the fraction of pizza Mia would have equals number of parts in context divided by the total number of equal parts. So in this one, we have 16 equal parts, and the number of parts in context, or the part that we are talking about, is 1. So our fraction would be 1/16. Now let's apply the method that we learned about multiplying fractions. That is 1/4 times 1/4 equals, the resulting numerator would be the product of the numerators. And the resulting denominator would be the product of all denominators. That is 1 times 1 divided by 4 times 4, which equals 1/16. So now we know the procedure we use for adding fractions with common denominators and the procedure for multiplying fractions is true. Now, if you do a scientific experiment, you always repeat the experiment before you confirm the hypothesis. So let's be a good scientist and repeat our procedure for another set of fractions before we confirm our hypothesis. Let's say in this example, let's find 2/5 times 1/3, which is same as 2/5 of 1/3. So if we apply the procedure that we use for multiplication of fractions, it would be 2 times 1, that is the product of the numerators, divided by 5 times 3, which is the product of the denominators. So we get 2/15. Let's use our area model to confirm this. So here we have a circle which represents one whole. So now we have to find 1/3 of the circle. So for that, we divide the circle into 3 equal parts. And the shaded area in blue represents 1/3 of this whole. Now let's find 2/5 of this 1/3. And how do we find that? We have 5 in the denominator, so we cut this into 5 equal segments. And how do we find the 2/5? Just shade 2 parts of it. Now to find the fraction that represents 2/5 of 1/3, we have to cut the whole circle into equal parts. So each third is cut into 5 equal parts. Now we have 5 equal parts in every third of the circle. Now to find the fraction that is shaded, we find the total number of equal parts, which is equal to 5 plus 5 plus 5. And what is the numerator? Is the part that we are talking about, which are these two shaded parts, which is equal to 1 shaded part plus another shaded part, which is 1 plus 1, which is equal to 5 plus 5 plus 5 is 5 added to itself 3 times. So that's 5 times 3. And our numerator is 1 plus 1. That is 1 is added to itself 2 times. That's 1 times 2, which is equal to 2/15. So we get 2/15 in both methods. So this proves our hypothesis.